Welcome, my name is Katie Stan. Today we're going to be talking about the laws of exponents. Our first topic we will be discussing is adding exponents. Adding exponents is set up like a multiplication problem, but all you're doing is adding the exponents. So our first example will be so you see this right here, you see a bunch of numbers and letters, but really it's very simple. I'll help you out a little bit. This part right here, the base, this is the exponent right here, and this number you'll sometimes see in front of here, in front of the base, is called the coefficient. If you don't see a number in front of the base, it's a 1. It's automatically a 1 right there. But the 1, when you finish off the equation, all you need is the variable. You don't need the 1 in front of there because it's automatically a 1, so it's just the base and the exponent. So when you add the exponent, you have this set up right here. All you do is take the exponent and add them two together. So 8 plus 11 is
19.
19. You have d to the 19th. But if you ever have a coefficient in front of the base, you have to multiply the coefficient, but you add the exponent. So an example of that could be 2a to the 5th times 3a to the 7th. So you see your coefficients right here, you multiply them. So 2 times 3 is?
6.
6. And you take the base over, and so now you add the exponents. So 5 plus 7 is?
12.
12. So your answer is 6a to the 12th. Pretty easy? Our next topic we will be discussing is subtracting exponents. With subtracting exponents, it's set up like a division problem, but all you do is subtract the exponents. It's kind of like adding exponents except you're subtracting them. So for an example could be a to the 15th divided by, or a to the 3rd. So you have your base, and you have your bases, and you have your exponents. But since you don't see a coefficient right here, it's just a 1, so you don't need to worry about it because it's just a 1. You don't need to put anything in front of it. So you have a to the 15th divided by a to the 3rd. So when you subtract the exponents, 15 minus 3 is?
12.
Equals a to the 12th. All you're doing here is subtracting the exponents. Nothing much to it, pretty easy. A to the 12th. Okay, let's see, I'll give you one with coefficients. So 15b to the 20th over 3b to the 10th. Since you have coefficients right here in the problem, coefficients you have to divide them. Adding exponents you multiply them, subtracting exponents you are dividing the coefficients. So 15 divided by 3 is?
5.
And since you're subtracting the exponents here, 20 minus 10 is?
10.
So to the 10th. 5b to the 10th. Any questions? Hope I'm not confusing you guys or anything.
No.
So that is how you subtract the exponents. And a little trick on subtracting exponents is if you have a really long problem and the number on top, the exponent on top is smaller than on the bottom, the number may come out negative, but you can't have a negative on the top. The negative has to go on the bottom of the problem. So another example could be 20x to the 2nd, y to the 4th, and z over 5x to the 6th, y to the 2nd. Okay, so for this one, you see the coefficient, and it's 4. So you have to divide the coefficient. So 20 divided by 5 is?
4.
4. The tricky part here is since this exponent on top is smaller than one on the bottom, it's going to be a negative number because 2 minus 6 is?
Minus 4.
Minus 4. X minus 4. And so y to the 4th minus y to the 2nd is?
2.
And then since z is just 1 by itself, z will just stay there because there's nothing underneath it to subtract it. So z will stay by itself. If there's a number without an exponent, it will stay by itself. So it'll just be z. But you can't have a negative exponent with the rest of it. You can't have a negative exponent on top, I should say. So if you ever have a negative exponent, you have to move it to the bottom. So it'll be 4y to the 2nd, z minus x to the 4th. Can never have a negative exponent in there. It has to be on the bottom.
Oh, okay.
Just has to be on the bottom. And so that's, it may look a little complicated, but it's really not. Do you guys have any questions?
No.
No? Okay. Whew, man. Our last topic we will be discussing is 0 power. This one is really easy. If you have anything to the 0 power always equals 1. No matter what, always equals 1. Say you have c to the 0 power, that will always equal 1. Pretty easy. And say you have an equation like x squared y to the 3rd, z to the 4th, to the 0 power. It's always going to equal to 0, always equals
1.
Always to the 0 power, always equals 1, I should say. That's how I could say it. Anything to the 0 power always equals 1. No matter what. Plain, easy, simple. You guys have any questions?
No.
Okay, I'm going to do a quick review really quick so you guys can get a bigger understanding of it. So adding exponents, you add the exponents, but you multiply the coefficient. You add so it's in the title. Add the exponents, adding exponents, you add the exponents. And the coefficients, you multiply them.
Okay.
And subtracting exponents, it's in the title again, subtracting exponents. So it may be set up like a division problem, but you're just subtracting them. And then the coefficients you divide. You divide the coefficients. Pretty easy. Any questions? And the 0 power is pretty general. It's pretty simple. Anything to the 0 power always equals 1. That's our lesson for today. And I'm going to thank you all for coming and listen to me talk. And I hope to see you guys in class.